Okay, so this lesson is on log equations. So essentially the main idea that we're going to look at today is building on what we did in the last lesson, where if we can, we're going to rearrange the log equations and put them into exponential form. And when we do that, it's going to get really simple and turn into equations we already know how to solve. So it has a few more steps in it than the ones we did in the last lesson. But if we look, our base is 3, and then we've got the 2 over here, and then here's what we're taking the log of. So if we're putting this into exponential form, we would have 3 squared. So the 3 comes from here, 2 comes from there, and then equals, and all of this that's in parentheses is going to go on the other side. So 3 squared is 3 times 3, so we can replace that with 9. And then suddenly this turns into the kinds of equations we solved back in 8th grade, which is awesome. So we're trying to get x by itself. You first undo the adding and subtracting. So I have minus 7. So add 7 to both sides. You get 16 equals 4x. We divide by 4. And you get 4 equals x. And so then that's the answer. So if you just have one log in the whole equation, that's how you do it. So this next one is the same. There's only one log in the whole thing. We're going to rearrange it. So the 6 we bring down, the 3 we bring from over here, which is a little weird, but that's how we put it in exponential form. And then it equals 4x plus 9. So 6 to the third you could do on your calculator really quick. 6 times 6 times 6 is 216. Equals 4x plus 9. And then once we have it set up like this, it's just equations we already know how to solve. So we subtract 9 from both sides. We get 207 equals 4x. Divide by 4. And this one does not divide evenly. It comes out 51.75. But that's okay. And if you wanted to check your answer, you could put this back in here and use the change of base theorem that we just learned about and make sure that it comes out to be 3. But that's how you do these if there's only one log in the whole equation. Okay, so now we're going to switch and look at a different kind of problem. This one has logs on both sides. And they both have the same base. They're both 10. And it doesn't really matter what this is. If it's on both sides, we can just kind of cancel them out. And then we get 2x plus 5 equals 5x minus 4. So if there's one log on the left and one log on the right and they have the same base, we can just get rid of them. There's a really complicated reason for why, but this is just the simplest way to take care of that. And then we just have to remember how to solve equations with x's on both sides. So I have 2x's here, 5x's here. So we're going to try to get them all in the same place. The easiest thing to do would be just subtract 2x from both sides. We get 5 equals 3x minus 4. Then we would add 4 to both sides. We get 9 equals 3x. Divide by 3. And we get 3 equals x. So if you know a few tricks, you can get rid of the logs. And notice there wasn't anything in front of the logs. It's just log of something equals log of something. That's the only time that trick works. And I only gave you one of those because that's pretty straightforward. Now the next one is very similar. So let's look at the next one. The only thing that's different on this one, I do have logs on both sides. They're both base 5, but I have this pesky 2 in front. So we're going to use that power property where we can take the 2 and put it over here on the x and rewrite it. So we'll have log base 5 of x squared equals log base 5 of 9. And then once you just have log here and then you have the same base, that's when you can get rid of those. And so we'll have x squared equals 9. And you square root that. And if you remember from last year or the year before, I forget, there's 2 possible values for x when you square root. You could get positive or negative 3. But -3 can't go into a logarithm, so x equals 3 is the only one that actually will work. Sometimes they'll both work, but if I were to put -3 up in here, if you remember from yesterday, we talked about you can't take the log of negative numbers, so we have to throw that one out. Okay, so let's go ahead and take a look at the next one, which is similar but slightly different. I have log base 7s on both sides, but I have this 2/3 in front. Don't freak out that it's a fraction. We're just going to put it as a power over here. So I'm going to have log base 7 of 8 to the 2/3 power. And we have learned in the past how to do these using roots, but for the sake of time, I would say you can also put this into your calculator, 8 to the 2 divided by 3 power. And so if you do that really quick, you will find out that it's just 4. So we just put that in the calculator using your power key. Or you can go back through previous notebooks and look how we did that with roots. And so now I just have log 7 and log 7 on both sides with nothing in front. So I can cancel that out, and we get n equals 4, and I don't have to solve anything else. Okay, so those 3 examples were all situations where you had one log on each side of the equation with just the same base on both sides. Now we're going to start getting into slightly more complicated problems, but if we use our properties of logs, we can make them into these kinds of problems. So in the next slide, notice I have 2 logs on the left side and 1 on the right, and they all have base 6. So what we want to do is we want to combine these. We want to condense the left-hand side, which is what we did in a couple lessons ago. So if I have this plus sign here, I can write these as one big log base 6 of x times 9, which I like to flip around and just make 9x. And that was just one of the rules that we studied before on how to do that to make it into one log, the condensing situation. And now I just have log base 6 on both sides. I can cross that out. I have 9x equals 54. So one-step equation now. Divide by 9. We just get x equals 6. Okay, everybody got it? So, sure you do. So on the next one, I want to condense this side again. I've got 2 logs on this side. I want to condense it. Remember, if there's a number in front, you want to turn that into a power first. So that would be log base 2 of x to the 4th plus log base 2 of 5. And you could do this all in one step. I'm just breaking it up to hopefully not be super confusing. And then I'm going to condense it further since it's plus. I can turn that into 1 log base 2 and the 5 and the x to the 4th multiply, so 5x to the 4th. Or x to the 4th times 5 if you prefer to write it in a more interesting way. And then this side is still just log base 2 of 405. Since we've got the log base 2 on both sides, we're just going to get rid of that. We'll have 5x to the 4th equals 405. So we're trying to get the x part by itself. Divide by 5 on both sides. And we get x to the 4th equals 81. So I'm going to take a moment to show you how we can solve this on the calculator. We're going to use the inverse, which is the 4th root of 81. And there's an interesting way to do that on the calculator. Okay, so let me put the calculator up here. I'll zoom out so you can see this in the calculator at the same time. So if you hit the math key, which is right here, just on this original menu, there's a bunch of roots and stuff. If it's not a square root, which you have a button for, and it's not the cubed root, which is this one, you can pick number 5, which is just a generic root. So you can just arrow down, or you can push the 5 key. And then it's going to give you a place to put the 4 and a place to put the 81. If you're using one of the older calculators, Doesn't quite look the same, but you'll type 4 and then you'll do that button and then you'll put in 81. It'll work. And if we calculate that with the enter key, we get 3. So x ends up being 3. And technically, it could also be -3 if this were just an ordinary x to the 4th equation. But because on our original problem that would put a negative inside this log, we don't worry about the negative. I feel obligated to talk about it, but it doesn't actually work inside of a logarithm. Okay, so next page of notes. Let me zoom in. This one looks a little weird because I've got a W in the middle of it. But we're going to use basically the same kind of thing. Notice there's a minus instead of a plus. We're still going to condense this side. So we're going to have log base 8, except with the minus we're going to use a fraction. So it'll be 48 over W equals log base 8 of 4. So we condensed it so there's just one log on each side. And then I can cancel out the log base 8s. And you get 48 over W equals 4. And then we've got to get rid of this fraction. Whenever you've got one of these, it doesn't matter whether it's the letter or the number that's in the bottom. You're going to multiply by whatever is in the denominator, the bottom. So I'm going to multiply by W, gives me 48 equals 4W, and then divide by 4. So we end up with 12 equals W. So the whole point of what we're looking at is you want to get everything into one logarithm on each side of the equation. And it's possible you could encounter problems that you have to condense the left side and the right side. I don't think there's anything like that on today's assignment, but just be aware you want to have one log on the left, one log on the right to make this work. Okay, so there's another kind of similar problem here. There's a little bit more work in here, but it's going to start the same way. So since I've got 2 logs on this side, we're going to condense those. So I have log base 3 of 4x plus 5 over 3 minus 2x. And when I put it into fraction form, I can drop the parentheses because this fraction bar acts as a separator. It groups them. And then look, this side doesn't have a log. So now we're going to go back to what we saw in the very first box. If I don't have a log on this side, I can't cancel this, but I can write it in exponential form. So I'm going to take this base 3, and then the 2 over here becomes the power, and then this fraction will just stay the same for a minute. 4x plus 5 over 3 minus 2x. So we got rid of the log by writing it in exponential form this time. We condensed, I'm going to write condense up there just so it's in my notes. So we condensed those, and then we wrote it in exponential form. So 3 squared is just 9. So I'm going to have 9 equals 4x plus 5 over 3 minus 2x. And I'm going to run out of box here, but I'm just going to go into the margin. It'll be fine. I don't want to write so tiny you can't see what I'm doing. So this is a little bit more complicated fraction, but it still works the same way. We're going to multiply by what's in the denominator. So I'm going to multiply this by 3 minus 2x. And I'm going to multiply this side by 3 minus 2x. And I use parentheses so that on this left-hand side, I will remember to distribute the 9 and multiply that by both of them. So I'm going to take 9 times 3 and 9 times the 2x on both of those. So that left-hand side becomes 27 minus 18x, and on the right side we have 4x plus 5. So this is kind of a lengthy problem, but we're getting closer because now we're down to just 8th grade math again, 8th grade, 9th grade math. So I have minus 18x here and 4x here. I want all of my x's on the same side. I could subtract 4x, but then that makes lots of negatives. I prefer to make them positive. So I'm going to add 18x instead and get rid of this term just because I like keeping things positive. So I get 27 equals 22x plus 5. Then you're going to subtract 5 from both sides. We'll get 22 equals 22x. This is going to be satisfying. Look how much we have simplified this down. We divide by 22. All of that work to get 1 is the answer. But that feels good to me because 1's a nice, simple number. We did all that work, and we got rid of a bunch of complicated stuff to get it to be just 1. 1 is a great number. 1 is the loneliest number. Okay, channeling my inner 70s child. Or is that 60s? I'm not even sure. Okay, one more box. So, on the left side, we're going to condense this first. So they're both log base 4s, so we can put it together. And since there's a minus, we're going to make that into a fraction. And the right side does not have a log. So unfortunately, on this one, I can't just cancel the logs off both sides. So I have to go back to what we looked to at the beginning of the lesson and write it in exponential form. So I'm going to have 4 to the first equals x plus 3 over 2 minus x. So 4 to the first is just 4. So if you want to take a moment and rewrite that again, you can, or you could just leave it. I'm just trying to be thorough. Okay, so then we have to get the 2 minus x out of the denominator. So we're going to multiply both sides by the quantity 2 minus x. So I did the right side, and I'm going to do the left side. And I put that in parentheses so that I will remember to distribute the 4 to both of those terms. So I will get 8 minus 4x equals x plus 3. And I'm at the bottom of the box, but that's okay. We'll just go outside the box. It'll be fine. So I've got minus 4x here, positive x here. I like to add more than I like to subtract, so I'm just going to add 4x to both sides. Get rid of that. So 8 equals, this would be 5x plus 3. It's getting simpler. Subtract 3 from both sides. We get 5 equals 5x. And it's just coincidental, maybe it's poor planning on my part, that we get 1 again. They will not always be 1. It just so happened to work out that way. So it's probably just me picking bad examples, but you just solve it like that.